This video is going to discuss when and why to use implicit differentiation, along with some examples of expressions of y being differentiated with respect to x and an example of an implicit function. Let's discuss when and why implicit differentiation is used. Up until this point, you've most likely been working with exclusively explicit functions, where y is solved for and equal to some function of x. With these, we know that x can calculate y directly. If we want to take the derivative of an explicit function, it would simply be dy dx equal to some function of x differentiated with respect to x. Contrary to this, we also have implicit functions, which is some function of x and y equal to something else, often another function of x and y. We know that x does not lead directly to y and y is not directly given. Implicit differentiation allows us to find the derivative of the function with respect to x even when y is not isolated. Now, before we go through a specific example, we're going to compare the differences between taking the derivative of a function of x with respect to x versus the function of y with respect to x. Now, on the right-hand side, I've noted that the derivative of x is equal to 1, whereas the derivative of y with respect to x is dy dx, or y prime. Now, in most cases, students have been using the chain rule and the product rule in taking the derivative of a function of x, but they don't realize it because the derivative of x is 1 and it simply cancels out. So in our first example, 2x cubed, we're going to use the chain rule and the product rule. Now, the chain rule says that the derivative of the outside times the derivative of the inside is the equivalent of the derivative of our function. So using the chain rule, we'd have 6x squared times the derivative of the inside, which would just be d dx of x, which is 1. So that gives us 6x squared times 1, which is just 6x squared. Now for our second example, we're going to use the product rule. So the derivative of the 4 is 0 times x plus 4 times the derivative, and I'm marking this down, d dx of x, which is just 1, would be 4 times 1 equal to 4. For our last example, we're going to use the chain rule again. So the derivative of cosine is negative sine of x times the derivative of the inside, which is our x, which is 1, will just give us negative sine of x times 1 equal to negative sine of x. Now let's look at when we're differentiating a function of y with respect to x, following the same process. So we're going to use the chain rule and the product rule here, giving us 6y squared times the derivative of the inside, which is just dy dx, giving us 6y squared times dy dx. Our second example will give us 0, because the derivative of 4 times y, plus 4 times the derivative of y, which is d dx of y, equal to 4 times dy dx. Now, our last example is going to be the chain rule again. So we have negative sine of y times the derivative of the inside, d dx of y, equal to negative sine of y times dy dx. Now notice the only difference here is all of these derivatives with respect to x versus respect to y either go to 1 in terms of x, or they go to dy dx when we're differentiating a function of y. This trips up a lot of students, but if you can keep this in mind, that will help you process any function that is thrown at you. With the information we learned from the previous slide, we're going to complete an example here. The steps we're going to be following are on the right-hand side, where first we're going to differentiate with respect to x, then we'll collect all dy dx to one side and solve. I've already written out that we're taking the derivative of both sides with respect to x. So here, the derivative of x squared will be 2x. Derivative of y squared times x will be the product rule, so x times the derivative of y squared will be 2y. And again, we're using the chain rule for y squared, so we will have times the inside, which is dy dx. We will then finish the product rule, which will be 1 times y squared, equal to derivative of the outside of sine of y for the chain rule will be cosine of y times the derivative of the inside, dy dx. We'll keep all terms not involving dy dx on one side and factor it out. From here, I'm going to divide both sides by this term, giving us 2x plus y squared divided by negative 2xy plus cosine of y is equal to dy dx, or y prime, and we've solved our problem. So just to review the key takeaways from this video, when you are differentiating an implicit function, you can almost always treat terms including y as being made up of two functions, and then apply the product or the chain rule. The steps to differentiating an implicit function is to first differentiate all terms with respect to x. Then you'll isolate terms with dy dx to one side of the equation and factor the dy dx out of it. From there, you're going to divide the remaining terms on the other side of the equation by the multiplicand to leave dy dx isolated and equal to your solution.